exponential growth function, and the limit notation will be lim of f of x will be positive infinity as x approaches positive infinity. And then the other limit will be lim of f of x equals 0 as x approaches negative infinity.
Now we're going to translate the function across the x-axis and up 6 units. So to do this, we're going to rewrite the problem as f of x equals negative 5 to the power of x plus 6. And that graph is going to go one, two, three, four, five, six. So our equation is f of x equals negative 5 to the power of x plus 6. So we're going to go up 6 units. And then we are also going to have a point at 1, 0. So this is going to create an exponential decay. Okay. Alright, our next problem is Shannon buys a jet ski for $25,000. Every year it depreciates by 10%. After how many years will a jet ski be worth $15,000? So for this problem, we're going to use the equation A equals P open parentheses 1 minus R close parentheses to the power of T. Now we are going to substitute in. We are trying to find when it will be 15,000. The original price was 25,000. 1 minus the depreciation rate, which is 10%. And we can turn it into a decimal, so it will be 0.10. Ooh, boy, that's bad. 1. So we are trying to find t, so that is our variable. So what we're going to do, we're going to divide both sides by 25. So now over here, we have 3 over 5 equals 0.90 to the power of t, because this 1 minus 0.1 equals 0.90. So now we have to change this into a logarithmic form. That's going to equal log base 0.90 3/5 equals t. You're going to have to do a change of base because this base is not equal to 10. So you're going to end up with log of 3/5 over log of 0.90 equals 4.85. Now the answer for our equation is 4.89 years. So after approximately 4 years, 4.85 years, her jet ski will be at the value of $15,000.
Okay, so we're going to want to plug in all of our values. So we're going to get up with A of t equals 5,000, 1 plus 0.05 over 4 because we're compounding it quarterly. And then t will be 10 years times quarterly, so that'll be 4. So we end up with 5,000, parentheses 1 plus 0.5 divided by 4 to the 10th times 4. So our first step is going to be to want to work out what we have in the parentheses, and that's going to give us 1.0125. And then we'll times that to the 40th, because 10 times 4 equals 40. That's going to give us 1.6436. And then we're going to plug that back in, and we'll have 5,000 multiplied by 1.6436, and we'll end up with a total of 8218.10. So after 10 years, Janet's investment is going to be worth $8,218.10. Great. For our last problem, we're going to compare the functions. Let's do red. Y equals 2 to the x and y equals x squared, and then we're going to show their end behavior. So we're going to start off with y to the 2x. Y equals 2 to the power of x. That's going to be, we're going to have one point at 0, 1, and another point at 0, 2. This is going to come on something like that. It's an exponential growth problem, and the end behavior of this one is going to be limit of f of x as x approaches infinity equals infinity. And then for this other one, it's going to be limit of f of x as x approaches negative infinity equals 0. So we're going to switch to blue and graph y equals x squared. So this graph is going to be a parabola. So we're going to have our point right there. We're going to go over 1 point, over 1 point, 2 up, 1, 2, 3, 4. And it's going to look something like that. And the limit behavior of this one is limit of f of x as x approaches infinity equals infinity, and limit of f of x as x approaches negative infinity approaches negative infinity, x goes to infinity. So that's all we have for today. Hopefully that helped you out.